There we go. All right, so here's protein synthesis. When we look at it, you can see that we have the nucleus. Now, inside the nucleus, we have our double-stranded DNA. Okay, now the first thing that has to happen, and I'm going to make transcription all in purple. Okay, so transcription is stage 1. I'm going to try and put it all in purple. So the first thing that happens is my DNA unzips. So number 1 is DNA unzips. All right, number 2, this molecule called RNA polymerase is going to bind to the promoter. I have not given myself enough space here, but that's all right. Promoter, that's fine. I just need to give myself a bit more space in my nucleus. All right. Now what happens is the RNA polymerase, number 3, RNA polymerase begins to move along the template strand, joining complementary RNA nucleotides to form, I know I said I'd keep it all in purple, but it's not going to work. Okay. To make number 4, which is the pre-mRNA is formed. And that's transcription. All right, so what's going to happen next is it's going to move along to the next stage. All right, that pre-mRNA is going to move along to stage 2, which is going to be your RNA processing. Okay, and with RNA processing, you're going to have this green strand here with all of these single-stranded bases. This is my pre-mRNA. And it's going to undergo a couple of processes. It's going to undergo a bit of splicing. So I'm going to label these guys here. I'm going to say these guys are introns. These guys are exons. So we're going to undergo this process of splicing. And that splicing process, I'm just going to make this nice and big for us. That splicing process will leave behind still a single-stranded piece, but it will just be made up of the 3 exons. In addition to that, I'm also going to add 2 things. I'm going to add a poly A tail, and I'm going to add a methyl cap. Okay, and what we've now formed is what we call mature mRNA. Okay, why do we add those things? We add the methyl cap and the poly A tail so that the mature mRNA doesn't break down, so that it stays intact. And we splice to get rid of the introns because they are the non-coding DNA. So it's all good and well. We've now done RNA processing. What's going to happen is that mature mRNA is going to leave the nucleus. Leave the nucleus. And it's going to come over. I really have done them on the wrong side, so I'm just going to redo that one. So here's my mature mRNA. Like this. This time it's going to have a ribosome attach itself. So when I've got to number these, so splicing happens, the methyl cap gets added, sorry, and the poly A tail gets added. So it comes over here. I'm just going to ignore the fact that those cap and tail are still on it. and the ribosome will bind. So number 1 is the ribosome binds to the mRNA. Okay, then along comes old mate tRNA. Okay, so here's my tRNA molecule. I'm just going to zoom in so you can see him a bit better. And on the back of that tRNA molecule, we're going to make these green. Okay, so we're going to have on the back of that tRNA molecule, we're going to have amino acids. If my codon is AUG, this here is my codon. On the other side, I'm going to have an anticodon, and that might be UAC. Okay, and that corresponds, that codes for a specific amino acid. You don't need to know what they are, you can read them directly off the codon table. So the number 2 point that we have down here is this bit here. So number 2 is the tRNA brings a specific amino acid, and I'm just using my codes just to help me so I don't take up so much space. It's going to bring a specific amino acid to the ribosome. That's my second dot point. Now what happens is that mRNA moves through number 3, and the mRNA moves through being read in triplets. So the mRNA moves through the ribosome being read in triplets or codons. And then the last thing you need to know is that as that happens, number 4 happens up here, which is a polypeptide chain of amino acids is formed. Okay, and that there is stage 3 translation. I'm just going to stop my recording.